Okay, now we're still looking at lesson 8-7, special cases, and this is one of my favorites. It's called difference of two squares. So recall from lesson 8-4 that a plus b times a minus b equals a squared minus b squared. And you can go through and do the math if you want. And so we can use the reverse of this and know that a squared minus b squared gives us a plus b times a minus b. So an example of this is if we have x squared minus 6 squared. If I can take the square root of both of these, square root of x squared, square root of 64, if they're perfect squares, I can say that x plus 8 times x minus 8 is equal to it. The same thing goes here. 25x squared minus 36 is equal to the square root of 25. X squared is 5x, and the square root of 36 is 6. So I get 5x plus 6 and 5x minus 6. So let's look at the problem 3. It says, what is the factor form of z squared minus 9? So z squared minus 9, I know that I can rewrite this as z squared minus 3 squared, and I get 3z plus 3 times z minus 3. And once again, I said you can check it, and they did it for us. So we know z times z equals z squared. And I know minus 3 times z gives me minus 3z. And then 3 times z gives me 3z. And 3 times minus 3 gives me minus 9. My minus 3z and my plus 3z cancel out. I'm left with 3z squared minus 9. And so there's a check of that. So let's look at what I have on my whiteboard for the got it. So I have v squared minus 100. I know that v, I can take the square root of that. And I can take the square root of 10. And so that means I can rewrite it as v minus 10 and v plus 10. Order does not matter. Same thing here, s squared minus 4 squared gives me s minus 4 and s plus 4. I hope this helps.